Let's do one more set of problems to make sure you can find the maximum and minimum of things. Let's find the critical numbers of these here. Well, what's the process? Are you getting tired of me saying it yet? F of theta, f of x, f of g, who cares? All you got to do is write it down, take the derivative, and set it to 0. That's how you find your critical numbers. This would be negative 2 sine theta plus 2 sine theta cosine theta. Did you get that one correct? Remember to pause and try these before you let me just solve them for you. Right? You don't want to do that. You want to practice these. So what do we do after we find the derivative? For a critical number, to use Fermat's theorem, to find the maximum or minimum, we set it to 0. Set the derivative to 0. Whatever this does, maybe it's something funky, maybe it's, okay, I can't do this part, but you get my point. Every single part where it changes direction, the slope is 0. And all you got to do is solve for it. Don't worry about the whole function. I can factor this out. We can do, let's take a sine out of this. Sine theta. I prefer to write it like this. That's negative 2. Oh, heck, we can take a 2 out of it. Why not? That'd be negative 1 plus cosine theta equals 0. Well, what values of sine are 0? Here's a circle. Sine is the y value. That's here and that's here. So that would be at 0 and pi. So far we know 0 and pi are critical numbers. And this one says negative 1 plus cosine of theta equals 0. So that means cosine of theta has to equal 1. Well, that would be cosine being an x value. That would be right here. And that only happens at 0. So these are going to be our only critical numbers of that function. Now notice how easy that was if you factor it. These are designed to be factored for you to have it demonstrated to you. And make sure to draw your unit circle too, right? Because we don't want to actually have to calculate things. You want to look at the unit circle and go, oh, right, I see. The only place that x is equal to 1 is at the edge of that over there. That keeps you from having to be a genius like some of these people in math classes are before you get an answer. And that's certainly not what I am. Okay, f of x equals, come on, x squared e to the negative 3x. How do I find a critical number? Take the derivative, set it to 0. So what's the derivative of this? Can you tell me? It's going to be some kind of a product rule. And you know product rule, we've done it a bunch of times. U prime v plus v prime u. So 2x e to the negative 3x plus v prime, which is going to be the same. Chain rule, negative 3 goes in front. And then the original v there. So what can we take out? Well, of course we can take an e to the negative 3x out. Let's start with that. So we get 2x minus 3x squared. So we can also take an x out of there. I think we're getting to the point here pretty quickly. Let's write it like this. This is equal to 0, so we can do all these separately. Here's 0, that's obvious. E to the anything is not going to become 0. There's nothing that you can make e to make it 0. Except maybe infinity? Because 1 over e to the 3 infinity should equal 0. So I suppose x being infinity in theory could be a critical number, which means like the function, no matter what it does, is going to be getting pretty flat at the end. And we say, okay, it has a slope of 0 at infinity. That's what that would mean to me. And then this one, okay, 2 minus 3x equals 0. Subtract the 2 over, or better yet, just add the 3x over to make it all positive. So you get 3x equals 2 and x equals 2/3. So we would get 2/3, 0, and infinity for this particular question. See how fast this work can be when you factor, factor, factor. Don't solve, factor, separate, find the 0. Critical numbers are very easy when you keep it that way. How about the next one? G of theta. The reason we're doing these quickly is you should be good at derivatives by now. This isn't about finding derivatives. You're supposed to know how to find derivatives. But finding when they're equal to 0, I mean, goodness, you should be able to do that in a heartbeat. G prime of theta. How do you find a critical number? You take the derivative and equal it to 0. What's the derivative of 4 theta? 4. The derivative of tangent, secant squared, theta. Set it to 0. No big deal. So we can say secant squared of theta equals 4. Well, what is that? Let's take a square root, and we'll say secant theta equals plus or minus 2. And what is secant? That's 1 over cosine theta equals plus or minus 2. Let's do it separately. If you inverse all of these, then that would be cosine of theta is equal to plus or minus 1/2. Right? Because this is 2 over 1, flip everything upside down, and this is what I get. So let's look at the unit circle. Go to where x is equal to 1/2, and you tell me, what's that at? I want to say, if I had drawn it correctly, that that's root 2 over 2 for both of these, for our x values. Or excuse me, root 2 over 2 is when it's 45 degrees. When cosine is equal to 1/2, that would be at 60 degrees. Root 2 over 2 is here, and 1/2 for sine is there, so that's root 3 over 2. So it would be this here. That's going to be pi over 3. And you could write it as negative pi over 3. I prefer to write it as 5 pi over 3. And then how about negative 1/2 on this side? Well, that's going to be, I'm going to say it's 2 pi over 3 there, and 4 pi over 3 here. So we get 4 critical numbers for this answer, where this is going to be true. But see how you can follow through with this without having to do a lot of math. If you know your unit circle, it really helps too. So far we've found that with critical numbers, you really want to know your quadratic equation and your unit circle. That is really where the trig and the algebra come together to form beautiful calculus. How about the next one, h of t? We're just whipping through them today. Equals 3t minus arc sine of t. How do you find the critical number? You take the derivative and you set it to 0. 3 minus, what's the derivative of arc sine of t? I bet you don't recall. I certainly don't recall, so let's find it. If I say y equals the arc sine of t, let's say it's x. That's the same as saying x equals the sine of y. Now let's take the derivative. d dx, we get 1 equals cosine of y. And let's remember our trigonometric identity here. This is always going to be important. Sine squared plus cosine squared equals 1. That's the Pythagorean theorem inside a circle. Okay, so what I'm going to do is I'm going to write this as 1 equals the square root of 1 minus sine of y squared. Because if you solve for cosine, this is what you get. This is the same thing, these two statements. But now I can use x equals sine of y right here. So I can write this as 1 equals, d dx, because we don't need the 1. It's d dx times 1. We'll leave it as the 1. And chain rule this, dy dx. Don't forget that's out there, as it's out here. I'm moving too fast. Is equal to the square root of 1 minus x squared dy dx. So divide this group out, and we can find that the derivative of arc sine of x in this case is 1 over the square root of 1 minus x squared. You might get to keep that on a note card. So let's just, that was kind of an aside while we solve this. I'm going to bring it out here just to remind us what that is, because I'm going to remove this little side solution. You might have to have it memorized, or you might get to have a note card, but neither of those are true for me, so I have to derive it whenever I want to use it. Okay, so derivative of arcsine of t is going to be, we're back to the normal problem now, the square root of 1 minus t squared, like that. So we get negative 1 over the square root of 1 minus t squared equals negative 3. I just subtracted that over. And we can make these positive now. Let's multiply and divide in all our special things. So we can say 1/3. If I multiply this up and divide this down, equals the square root of 1 minus t squared. We'll square both sides to get rid of that ugly root. I hate square roots. Truly I do. So we can subtract the 1 and divide however you want to work this out, but I get t squared equals 8 over 9. No, wait a minute. If I subtract 1 here, it should be negative 10 over 9. No, yeah, 8 over 9. 1/9 minus 9/9 is negative 8/9, and then we have 2 negatives to get rid of. And we'll square root. So I get t equals plus or minus the square root of 8, which is 2 root 2, over 3. Those are going to be our two critical numbers for this problem. No big deal. You got to be able to find your arcsine, but we do that all the time. This is like the 15th time I've derived it in this video series. I'm sure you've seen it a couple times by now. Surely you're not dropping into video number 136 as your first video, so I hope that you have derived arcsine a couple times with me already. Last problem, f of x equals x to the negative 2 ln of x. Well, what is this? How do I find a critical number? You take the derivative and set it to 0. Well, what are these? These are two multiplied functions of x, so that's going to be a product rule, u prime v plus v prime u. Let's just worry about the next step. U prime is negative 2x to the negative 3 times ln of x. That's ugly. Plus 1 over x, I like that better, times x to the negative 2. Let's break it down. We get, I don't know how to make this any better, negative 2x to the negative 3 natural log of x, plus, this is x to the minus 1 times x to the minus 2. We should get x to the minus 3 here. Ah, we can factor. Okay, so 0 equals x to the negative 3, negative 2 ln of x plus 1. This means that x can be 0 if it's just by itself. And now let's do this one. Negative 2 ln of x plus 1 equals 0. Subtract the 1, divide by negative 2, and we're going to get ln of x is equal to 1/2. So that means x is going to be what? I don't actually know that. I think if we do e to the both of these, this goes away. So it would be, I'll make some room here. X equals e to the 1/2. That's going to be our other critical number there. Yeah. So that's going to be the answer for this one. How did we accomplish that so quickly? Well, step by step, you're going to take a product rule and then find out where it factors here. Separate them and have your x values individually marked to 0 and just work through the algebra. We've done a lot of e to the natural log and natural log manipulation in this class, but I think you're starting to notice that now that we know derivative rules, this is all about doing algebra. Okay, let's move on to the next problem set and rock it with some word problems.